Welcome to the lesson on laws of exponents for real numbers. At the end of this lesson, you will be able to apply the laws of exponents to real numbers. The collection of rational numbers and irrational numbers together make up the collection of real numbers, which is denoted by R. We know that mathematical operations such as addition, subtraction, multiplication, and division can be applied to the collection of real numbers. Can we apply the laws of exponents to real numbers? Let's verify the first law. Consider the term 2 raised to the power of 5. Here, 2 is called the base and 5 is the exponent. This term can also be written as 2 multiplied 5 times. Now, let's multiply the term with 2 raised to the power of 2, which is equivalent to 2 multiplied 2 times. The product obtained is equal to 2 raised to the power of 7. Can you see the relationship between the exponents of the three terms? Yes. The exponent 7 is equal to the sum of 5 and 2. Let's consider another example. Here, 2 are the two bases with exponents 2 upon 3 and 1 upon 3. Now, let's simplify it. Based on these examples, we can generalize the first law of exponents. This law states that when multiplying two numbers that have the same base, you can add the exponents. Here A is a real positive number. M and N are rational numbers. Next, let's verify the second law of exponents. Consider another example. Here, we are dividing two exponential terms. The numerator and the denominator can also be expressed as follows. On simplifying, we get. Do you see a relationship between the exponents? Yes, you're right. 5 minus 3 is equal to 2. Let's apply the observation of this example to simplify another example. Based on these examples, we can generalize the second law of exponents. The second law states that we can divide two numbers with the same base by subtracting the exponents. Here A is a real positive number. M and N are rational numbers. Consider another example. This can be written as follows. On simplifying, we get the result as 1. Now, let's verify this example again by applying the second law of exponents. If we equate the solutions obtained by both methods, we get the following expression. Based on this result, we arrive at another generalization. Any non-zero real number raised to the power of 0 is equal to 1. Let's move on to verify the third law of exponent. Consider the next example. Here we have two terms, 2 raised to the power of 5 upon 2, the whole raised to 2, and 2 raised to the power of 5. Can you see a relationship between the exponents of these two terms? Let's examine the first term. Applying the first law of exponents, we can express this term as follows. On simplifying the first term, we arrive at the fact that the two terms are equal. This implies that if an exponential term is raised to an exponent, then you can multiply both the exponents. Based on this example, we can generalize the third law, which states that to raise a power to a power, just multiply the exponents. Here a is a real positive number. M and n are rational numbers. Let's verify the fourth law of exponents. Consider this example. Let's consider another example. The exponent 2 upon 3 is common. Hence, we can multiply the bases. The answer is 15 raised to 2 upon 3. The fourth law of exponents states that to multiply two numbers with the same power, raise the product of the bases to the same power. Here, a and b are real positive numbers and m is a rational number. Similarly, two different bases with the same exponent can be expressed as follows. This is the fifth law of exponent. The fifth law of exponents states that to divide two different numbers with the same power, you can raise their quotient to the same power. Consider this example. Here, we have to divide two exponential terms, 7 raised to 2 and 8 raised to 2. The exponent 2 is common for both the terms. Therefore, this can be expressed as 7 upon 8 raised to 2. So far, we have seen examples where the exponents were all positive rational numbers. Can the exponent be a negative rational number? To verify this, let's consider an example. Applying the second law of exponents, this expression can be written as follows. The answer is 7 raised to minus 3. This can also be simplified as follows. On equating both the solutions, we get the following result. With this, we arrive upon another important generalization. Any real number raised to a negative exponent is equal to the reciprocal of that number raised to an equivalent positive exponent. This brings us to the end of the lesson on the laws of exponents. To summarize, we have verified that all the laws of exponents can be applied to real numbers. Here, a and b are positive real numbers, and m and n are rational numbers.